Net ionic equation are reactions that show only the elements, compounds, or ions directly involved. We must always use a solubility chart. On tests and quizzes, you will be provided a solubility chart just like the one you have in class. You need to just know how to use it. So to use a solubility chart, you must look up the anion. If you look at the first column here, it is the anion. After I look up the anion, I look up the cation. So I go across, and the second column is my cation. Anything that's soluble is AQ. Anything that's insoluble will be a solid. So for example, if we have aluminum nitrate is AlNO3, 3. So I look up, number one, the anion, which is nitrate. So if I look up nitrate, which is right here, then I go look up the cation. The cation, it says any cation, it is always soluble. So that means this will get an AQ. Here's another example. So if I have zinc sulfide, I look up the anion, which is the sulfide here. Then I go to the next column, which has the cation. So if I look at the top row, I don't see zinc at all. Those on the top row are soluble. Since zinc is not on the top row, we go to the bottom row, which says any other cation, low solubility or insoluble. So zinc sulfide, it gets an S. Remember, from our symbols, S means there's a solid. That's why it's insoluble. We also need to memorize the strong acids and the strong bases. The strong acids are mainly from group 7 or the halogen family. It is HCl, HBr, and HI. The other three are HNO3, H2SO4, HClO4, and technically HCO3. Strong bases are pretty much from everything from group 1 except for hydrogen, because the HOH produces water. In group 2 is calcium and below. So calcium, strontium, barium, radium. Do not look up calcium on the solubility chart because it will state it is insoluble. But for honors and AP chemistry, it is always considered to be aqueous or soluble. All strong acid and strong bases, unless given in a different state of matter, will be aqueous. And they will dissociate. Dissociate means they will break into ion. So for example, if I have HCl, HCl will be AQ. So it will break into its ion, which is H plus, AQ, and Cl minus, AQ. Same thing for bases. If I have radium hydroxide will be AQ. So it will break into ions. The two ions that make up radium is Ra2+, AQ, and OH minus, AQ. Molecular equations are complete balance equation. When you write a complete ionic equation, you break down or dissociate any substances that are aqueous except for weak acids into its ion forms. Net ionic equations are only the equations with ions, elements, and compounds that are involved in the reaction. Spectator ions are the ions present in the reaction but does not participate. So you could think of it as if you go to a sporting event, you watch as a spectator. You don't go in and shoot a basket or score a touchdown. The word dissociate means that you break down the compound into its ion forms. Anything that's aqueous will break down except for weak acids. Later on, when we get to the acid-base chapter, weak acids will also dissociate to a certain amount. But when we are talking about AQ, for this unit, when weak acids are aqueous, we do not break them down. So in general, solids, liquids, gas, AQ that are weak acids do not dissociate or break down into ions. Driving forces in chemistry are the reason why reactions occur. There are 4 types: formation of a solid or a precipitate. Precipitate is another word for solid. Formation of a water, so H2O, whether it is liquid, gas. Formation of a gas, so if you see bubbles, that is another driving force. And the 4th one is the transfer of electrons. These are the oxidation reduction equations that we will cover later in the school year. Most single replacements are transfer of electrons or an oxidation reduction reaction. So for every reaction, if nothing is given except for the reactants, we are going to determine the type of reaction. So we have sodium hydroxide. We know this is a compound. We also know copper 2 sulfate is also a compound. So this is going to be a double replacement reaction. We're going to write the names of these compounds into symbols. Sodium hydroxide is an ionic compound because sodium is a metal. So we need to find the symbol and charge. So Na has a charge of 1. Hydroxide has a charge of 1. So NaOH. Copper 2 sulfate is also an ionic compound because it starts with a metal. So Cu has a charge of 2. Sulfate, SO4, has a charge of 2. It reduces out, so this becomes CuSO4. So since this is a double replacement reaction, Na and Cu are going to swap partners. Remember, metals replace metals. So Na's new partner is SO4. The charge of Na is 1. The charge of SO4 is 2. We cannot reduce, so we crisscross. So this is going to be Na2SO4. Please note that the 4 subscript is only carried through because sulfate is SO4. No other subscript is carried through. The reason Na has a subscript of 2 is because the charge of SO4 is 2, the charge of Na is 1. So to have a neutral compound, I need 2 sodiums to 1 sulfate ion. So copper's new partner is going to be OH. The charge of copper was 2. It will carry through as 2 unless otherwise given. Hydroxide OH has a charge of 1. We cannot reduce, so we crisscross, plus Cu parentheses OH parentheses 2 because hydroxide is a polyatomic. Next we balance. So if we put a 2 in front of sodium hydroxide, everything else is balanced. Now using your solubility chart, we need to find the states of matter. Sodium hydroxide is aqueous. Why? It's a strong base. It is one of the ones I asked you to memorize. It is in group 1. Copper sulfate is aqueous. So we look up the anion, which is SO42 minus. SO42 minus is always soluble except with silver plus 1, Ca calcium plus 2, strontium plus 2, barium plus 2, and lead plus 2. So with these 5 ions, it will always be a solid. Since copper is with sulfate, it is AQ. Sodium sulfate is also aqueous. The other way you could do that is anything that's with group 1 in general except for hydrogen is always soluble. Copper hydroxide is a solid. It is a weak base. OH minus is always soluble with group 1 except for hydrogen because HOH makes water, and then group 2 calcium and below, so calcium 2 plus, Ba2 plus, Sr2 plus, Ra2 plus, and ammonium. So copper hydroxide is a solid. What we just wrote is the molecular equation. So now everything that is aqueous, we're going to break it apart. So NaOH is a strong base and it's AQ, so we're going to break it apart. The two ions that make up sodium hydroxide is sodium, which is a positive charge. It's aqueous. There's two of them because you have a coefficient of 2 plus 2OH minus AQ because there's a coefficient of 2, so that's 2 times 1. Copper sulfate is also aqueous, so we are able to break that down. Cu2 plus, that's the charge of copper, AQ, plus SO4 2 minus AQ. Sodium sulfate is also aqueous, so we could break it down into its ions. Na plus, there is 2 of them because it's a subscript 2. However, there is only one SO4. Sulfate is a polyatomic and it is SO4. Copper 2 hydroxide, we cannot break it apart because it's a solid, so we leave it as is. What I just wrote here is my complete ionic equation. Complete ionic equation is we break down everything that is aqueous except for weak acids into its ion form. So that means you need to find its charge either on the periodic table or the polyatomic sheet. Now we're going to simplify. Just like in math, we're going to reduce. We can only simplify things that are exactly the same on both sides. We have 2Na plus AQ. We have 2Na plus AQ. Sorry, I forgot to write the AQ here. So they cancel out. 2OH minus on the reactant side, but there is none on the product side. The OH is combined with Cu, so they're not the same. The Cu2 plus on the left side, the Cu is combined, so they're not the same. SO4 2 minus AQ on the left side, and there's exactly the same SO4 2 minus on the right side, so we could cancel those out. So what we have left over is 2OH minus AQ plus Cu2 plus AQ yields CuOH2 solid. So we have 2 OHs on the left side, 2 OHs on the right side, 1 Cu and 1 Cu. So the equations balance. This is called the net ionic equation. Net ionic equation are the ions, elements, and compounds that are involved in the reaction. So in this problem, when we mix sodium hydroxide and copper 2 sulfate, what happens is we form a solid. And to form that copper hydroxide solid, we need OH minus ions and Cu2 plus ions. 2 ions we canceled out, the Na plus AQ and the SO4 2 minus AQ. These are called spectator ions. They are there but do not participate in the reaction. What is the driving force? What caused this reaction to occur? It's the formation of a solid. So on the product side, we look at what is formed. A solid is formed. So the driving force is the formation of a solid. Number 2, we have a sulfuric acid neutralizes sodium hydroxide. Sulfuric acid is compound. Sodium hydroxide is a compound, so this is going to be a double replacement reaction. Sulfuric acid is an acid. All acids starts with an H for you right now. H is a charge of 1. Since there's no hydro in front and it ends in ic, this is sulfate, so SO4. Charge of SO4 is 2 minus, crisscross, so it's H2SO4. It is neutralized by sodium hydroxide. Sodium is a metal, so this is an ionic compound, so we need to find the charge, Na plus, OH minus, so cannot be reduced, so it's NaOH. Since it's a double replacement, the hydrogen will behave like a metal, and the acid, because it's at the beginning, will replace the sodium in the hydroxide. When you do that, we have H, charge of 1, will combine with OH, which has a charge of 1. If you notice, that is water. I'm going to write water as HOH. You could write it as H2O. It is up to you. Na's new partner, I'm going to find that charge, which is 1. It's going to be SO4, which is a charge of 2 at crisscross. So this is Na2SO4. So if we balance this, we have 2 H's on the left side. We have 1 H on the right side, so I need a 2. I'm going to keep my OH's together because they appear on both sides. There's a OH from the sodium hydroxide. There is 2 OH's from the water, so I need a 2 in front of sodium hydroxide. There's 2 Na, 2 Na, it is balanced. Now we're going to simplify this equation. So I'm going to separate the reactants from the products. So I see 2H plus on the left side, but there is no H pluses on the right side. The hydrogen that's present is combined with water, so it's not an ion. So I cannot cancel out the H plus AQ. Next, I look at SO4 2 minus AQ. We find it on the left side as well as the right side, exactly the same. They cancel out. 2Na plus AQ, we find it on the left and the right. They're exactly the same, so they cancel out. The OH minuses will not cancel out because it's combined in the product side, so it is not free. So what is left over is 2H plus AQ plus 2OH minus AQ yields 2H2O liquid. This can be reduced. The 2's cancel out. So this is H plus AQ plus OH minus AQ yields H2O liquid. So this is our net ionic. This is what is happening in the equation. So when I mix sulfuric acid with sodium hydroxide, what's happening is water is being formed. The 2 ions that we cancel out, which was SO4 2 minus AQ and Na plus AQ, these are my spectator ions. What caused this reaction to form, we look at the product side, is the formation of water. So that is our driving force, formation of water. Next, problem 3. Pause the video, try this on your own, and then check your answer. So hydrofluoric acid is a compound. Barium nitrate is a compound, so we know this is a double replacement reaction. Hydrofluoric acid is an acid. All acids begin with a hydrogen. Since it's a hydro, it is off the periodic table. This is fluorine, so that's 1. Crisscross, so hydrofluoric acid is HF. This is going to react with barium nitrate. Barium is a metal, so we know this is an ionic compound. Charge of barium is 2. Nitrate is 1. Crisscross, so this is Ba, parentheses, NO3, parentheses 2. Since it's a double replacement, we know the hydrogen and the barium are going to swap places. So barium's new partner is F, so Ba. Charge of Ba is 2. F charge is 1, so I crisscross. This is Ba, F2. Plus hydrogen's new partner is NO3, so it's 1, 1, so this is HNO3. So now I need to balance. To balance, I have 2 fluorines on the right side, so I need a 2 in front of HF. This causes H to have 2, so I need a 2 in front of nitric acid. And so there's 2 NO3s, 2 NO3s on the left side, 1 barium on both sides. So this is balanced. So we just wrote the molecular equation. Now I need to find my states of matter. Hydrofluoric acid is an acid, so it's going to be AQ unless otherwise stated. Barium nitrate is going to be AQ. So you look up NO3 minus. NO3 minus, pretty much everything is soluble. So it's AQ. So we look up fluorine, and fluorine, it's not soluble with barium, so this is a solid. This is an acid, nitric acid, so that's AQ. What we just wrote is our molecular equation. So next, I'm going to break down everything that's AQ except for weak acid. HF, hydrofluoric acid, we cannot break it down. It is not a strong acid, so we leave it together, even though it's a AQ here. Now we're going to break down everything that's aqueous except for weak acid. HF, hydrofluoric acid, is a weak acid, so we do not break that down. So we just copy it exactly as is. Barium nitrate is aqueous. It is made up of barium 2 plus AQ plus there's 2 nitrates, so 2 NO3 minus AQ yields barium fluoride is a solid, so we keep it together. Nitric acid is a strong acid, so we break that apart. There's 2 hydrogens, 2 nitrates. What we just wrote here is our complete ionic equation. Now we separate the reactants from the products and simplify. Anything that is exactly the same on both sides we can cancel out. We cannot cancel out hydrofluoric acid because the fluorine is combined with barium and the hydrogen is an ion on the other side. We cannot cancel out barium 2 plus because it is combined with fluoride. NO3 minus can be canceled out because we have 2 here and 2 on the opposite side, so that cancels out. I recopy what is left over. 2HFAQ plus Ba2 plus AQ yields BaF2 solid plus 2H plus AQ. Right here is my net ionic equation. When I mix these 2 compounds together, this is what is resulting. I have a spectator ion, is the one that I canceled out. It does not participate in the reaction. The driving force here is the formation of a solid or a precipitate.